Hi, everyone. Welcome back to another episode of the engineering side of data. We're going to be talking about data engineering at the edge. I'm joined by Mario Pereira. Hopefully I'm close on that last name. I'll let it pronounce it correctly. Mario, thank you so much for joining me. Please introduce yourself.
Thank you for the invite, by the way. So, hi, my name is Mario Pereira. I'm from Portugal, but I'm currently living in the Netherlands, and I'm working as a senior engineer at Voltpack. For the people that are listening to this podcast and doesn't know Voltpack is the leading independent liquid storage company. It's a Dutch company with 107 years old, so currently the oldest Dutch company. What Voltpack does. So Voltpack stores vital products, critical vital products in liquid state, like oil and gas, industrial chemicals. So everything that is critical for our lives in liquid state. Currently, we have 73 terminals. When I mean terminals are locations, facilities with tanks. Currently located in 23 countries. As a company, Voltpack is going through a massive digital transformation. During this process of digital transformation, where we are replacing our ERP, for example, or CRM, our management team understood that we don't only store vital products, we store vital data too. And these data can be useful not only for Voltpack itself, but for customers and partners. I'm here to talk about Edge, data engineering at the edge, is because at Voltpack, so the oldest Dutch company, built a product. So we built an industrial edge computing platform that currently enables and support internal industrial IoT initiatives, BI initiatives, and machine learning / AI initiatives. Our platform, our edge computing platform, currently at the moment, so what it does, it ingests data from at the edge, processes at the edge, stores temporarily at the edge, and then sends it to the cloud to enable the other initiatives.
That's excellent. So it sounds like quite a lot of activity over at Voltpack, a lot of digital transformation, like you mentioned, and your piece of it is the edge piece, the IoT piece. So IoT, Internet of Things, how many locations, how many sensors are we talking about?
So currently, right, as we're recording this podcast, we have from the 73 terminal locations, we are live in 18. Around these, we have an average of 20,000 sensors, 30,000 sensors. It really depends of the size and the type of the location. We have one location that has around 65,000 sensors.
That's incredible. Yeah. Wow.
Yeah. Currently it's a lot of data that we process at the edge and store and transform. Currently, in average, we are processing 65 million events per day. So, and storing in the cloud around 8 billion records events. I will explain later on.
Wow.
The architecture.
So incredible amount of volume, right? Yeah, no kidding. Can you describe like the early stages of the project? What were you doing? Actually talk about the goals as well of this project, if you wouldn't mind.
The early stage, we started very small because it's a very old company. With this, it comes processes, and fraction against daring to new technologies, right? And new methodologies. So we start very small with the prototype. We used only one sensor. We tested multiple products and tools in the market. Unfortunately, the industrial IoT sector or segment is very fragmented. We have one tool that is very good at ingesting, another one that is very good at transforming, another one that is very good at storing and exposing, but there is at our scale, it's very hard to find one that is very good in all and still ship. Okay.
Yeah.
So it's our goal to provide data that allows people to go home safe. It could be that we are able to provide data to the AI team and they do predictive maintenance. We have drones, for example. We can fetch this information from drones that is doing inspection. So we don't need people to go to hazard places and fall and die or suffocate inside the tanks. It unfortunately can happen. So safety, it's one of them. Of course, we have goals that to improve our assets. So like performance monitoring, the predictive maintenance is one very important goal, because if in a scale of things, if you for example, if one pump breaks down and it's stopped for 2 months because it's a lot of time it takes to replace the machine, it's a lot of money that and the product. It can happen that we already saw countries being stopped because we are not able to pump out. So
so it's certainly a productivity piece of that. So safety, productivity. Making sure that operations are streamlined as much as possible, and people are able to do the business they need to do. Can you talk a little bit about the architecture of the solution?
Yeah. So first in mind, I want to tell people that are listening to this, we start doing this development and research in 2018. Okay, in 2018, barely no one was doing this. So we went through an innovation path, okay, a lot of trying out. So in our architecture at the time, we used AWS services. Right now, if you go to the market, AWS, Azure, Google, they all provide this type of services out of the box. So you don't need to do all this development. But at our stage, at our scale, we really need this.
Doesn't it happen a lot? As soon as you develop a solution, somebody says, "Here you go. This is everything you just built."
Correct. But in our case, we have a very good relationship with Amazon and all our suppliers because we help them, they helped us. So we had a lot of contact with Amazon, not only Amazon and their partners, and they built a tool lookalike that is site-wise. But going back to the architecture, so what we have AWS IoT Greengrass Core. Greengrass Core, it's quite awesome from a technology nerd. It allows you to run AWS Lambdas locally, like in Raspberry Pis, in small boxes. So what we have 3 Node.js Lambdas, okay? One that runs OPC-UA client. For those that are not aware of what is OPC-UA or work in the industrial field, it's a very standardized protocol that all industrial suppliers provide. It's like a machine-to-machine communication protocol. And we have an OPC-UA client, Lambda, that ingests the data. Then we have another Lambda that we call it normalization Lambda, which is transformation Lambda, that grabs the data. This is, by the way, using MQTT. Greengrass Core already comes with a pre-built MQTT. We subscribe to the payload that comes from OPC-UA. We transform the data. We have business rules, like in order to give meaning to the data, the meaning that comes from OPC-UA, from an IT perspective, software engineering perspective, BI perspective, doesn't have a lot of information, so we need to give some context to the data. After giving that, we have then a storing Lambda locally that stores temporarily the data. The normalization sends the data to the cloud too. By the way, this data, before going to the cloud or being stored, is filtered too. Okay,
Oh, you said filtered? Is that correct?
Yes.
Okay.
Yeah. We use deadband, for example. If you look at we collect from a lot of things, not only tanks, flow meters, pumps, but if you look at the tank, when you are pumping in or pumping out, there will be a lot of movement. And maybe we don't want, because that will cause a lot of noise, and giving so much data to data science team is not, for example, or BI team is not very useful. Okay. So we reduce a little bit of the data, use deadband, we use some we use an algorithm to reduce the data too before sending to the cloud. Yeah.
So you have a series of fairly complex algorithms that help you filter this data, right? So you're removing the noise and hopefully providing only the data that is useful to data scientists or BI systems upstream of you. Okay.
Yeah. For example, ERPs and CRMs used to. Even our customers, we have an application that is called My Voltpack, which the customer can use and see the status of the tank. They can see, okay, how much tank my liquid has. If I'm a Shell or a Texaco, or I can see what is the status of my liquid inside the tank, how much it is there. So our data goes really from down to can even reach the customer. But I forgot to mention, in the cloud, we kind of mix. It's a little bit like a Kappa architecture, is where we mix batch and streaming. Okay, so for example, for the data science team, we use it as batch. It's a service that batch data to an S3 bucket of the other team when it's reaching the cloud. For another team inside of the BI, we use Kinesis for streaming the data, so they have real-time data on their side. So it's a little bit of a mix. And then we provide this data is stored in a MongoDB running in AWS. We provide.
Oh, so that MongoDB is that MongoDB running locally at the facility?
Yes, locally and in the cloud.
Okay.
So in the cloud stores all the data from all terminals, from all locations, not all, but filtered. And locally, we have a MongoDB too, okay, with an API in case of a local application wants to access it.
Sorry to interrupt you, Mario, but you were saying Kappa architecture earlier. Is that so? That's a very popular, pattern was Lambda architecture for the longest time, where you have a different way you ingest streaming versus batch. But Kappa has come along and said, "Hey, we can combine these, so you're not writing duplicate business logic." Is that what you're referring to?
Yeah. And it's kind of funny. Our Kappa architecture is so built on this. Is, for example, in OPC you can do batch data. So because it can happen, for example, the location, the terminal wants to see its what is the value now, or wants to see the real-time value. So it's a mix of business logic, yes. And this mix comes even from the OPC So on the OPC in the cloud, there is this very mix of technology and methodologies and architecturals in all the platform. Going to the API, so we have an API in the cloud, and locally that provides this data, for example, to ERPs, CRMs, with information regarding tanks or the flow meters. So we have multiple communication channels to multiple teams, okay, in order to scale better. From, as I told you, in the AWS part or other technology, we are constantly still looking for other products. How can we evolve our product? We can provide dashboards, maybe. We can even use something from the shelf. and we're already evaluating how can we migrate these to a IoT site-wise edge from Amazon, but it could be from Google, it could be from Microsoft. We are constantly checking. Yeah.
Excellent. Now, you've kind of alluded to some of the challenges of data engineering at the edge, working with IoT data. Could you elaborate on some of those challenges, some of the stuff that maybe a lot of data engineers take for granted? They're not used to working within these constraints, but yeah, shed some light on that if you could.
I will try to be as short as possible because at our scale there is a lot of challenges every single day. But I think the one is the first is I think I already mentioned a little bit is the context contextualization the data, the raw data that comes from the sensor. It gives not very many. It gives the value, so the status of that sensor. So the temperature is T3, but when it comes out, it comes like tank. Every tank has an ID. Every sensor has an ID, but it comes like a string, which is like TK004.CV23. This is the raw data, which is not very meaningful. And when you do it this at scale in a lot of terminals, and all sensors are different in all terminals. It's not something that is standardized, and the data will come totally different from all sensors. The capability to contextualize this data at the scale, grabbing all information from the sensor. Sometimes it's even it's a person. You need to grab this information from a person. What is this? What is this meaning? And then you create a business rule for it. As I already told people, I think people is a very big challenge. The problem is because we are talking about people with different backgrounds. Okay, industrial engineers, electronical engineers, from different cultures and different countries. I'm Portuguese. I have my ways of working. The Dutch have their way of working. The Chinese have their way of working. Americans have their way of working. Keeping people sync in different time zones. And we are a very small team. And with different expectations too, because sometimes people think, oh, you're going to grab the data and do already the machine learning and the AI. No, for machine learning, we need like 5 years of data. We need to study the data, do some analysis over it. It takes time. Another one that I was saying about the data, the TK00CV, is maintaining, because every day sensor is replaced. There is new sensors, more sensors, or removed sensors, or sensor gets broken. So maintaining the tags, the PCA tags, it's how it is called, in all terminals.
Maintaining those attributes must be quite a job within itself.
Yeah, so it's 30,000, imagine 30,000 attributes per location. People are changing constantly the tags, information. Then people, now I see the BI team opens a ticket saying, so it's more operational situations. Of course, we have monitoring in place, data quality in place. But sometimes it happens that we don't catch it. So now says bad status, bad code. What happened?
Is there a movement within Voltpack to standardize on sensors? You mentioned that maybe one terminal has one type of sensor from a manufacturer. Another terminal could have a similar type of sensor, but from a totally different manufacturer. So it has different attributes. Is there a movement to say, hey, let's standardize across Voltpack?
Yes, there is. At our main office, currently there is the initiative to standardize the suppliers, to standardize the tags, to standardize this information. The problem is you have very recent terminals, which we can do it very easily. And then we have old terminals that is way more harder to do. And the reason is because you need to shut down the system to replace it.
Yeah. Yep.
And
so over time, right? There's investment in the current sensors. You just can't go ahead and shut down for the day and replace them. And I'm sure that terminals have gotten used to making their own decisions. They probably have their own operating budgets, and therefore they purchase accordingly. I'm sure the numerous challenges there, and they'd rather put that problem on Mario. So
Mario or the rest of my team. I didn't told yet, but my team is still very small for our scale. It's even very. It's like a use case inside of Voltpack that a team that is it's me, another engineer that is backend, DevOps as me, an industrial engineer, so 3 people, and then we have the team leader. Project manager, team leader attends majority of the times. Meetings still has background of technical. I was lucky to hire really good people, which is nowadays is very hard to hire people to build a system that is maintainable, scalable, and it works well. I can sleep at night. I already been in tech startups that was not. It was very hard to be awake at night. I was constantly being awake at night. So. We have a very small team. We built a very big product, and people are like looking at us and say, "Hey, it is possible to be done with a small team." So we kind of use case even. So when people look at standardizing stuff inside of the company, even if the small company and if a small team can change so much in the company, I think it is doable. Going back,
very powerful.
Going back to the challenges. I already spoke about monitoring and logging, logging and tracing, data quality, checking the processing time. For example, the processing time. Just like before this morning, we had an incident where the time zones on the servers were different. And this causes a huge impact in our monitoring because we have timestamps. We have the timestamp of the sensor. We have timestamp of the OPC-UA server. We have the OPC-UA of the edge server. We have the timestamp on the normalization when the normalization happened. And we have the OPC, the timestamp when we store the data, we ingest the data. When one of the timestamps goes off-roads or stop syncing, it causes a lot of problems, on the data quality, on the processing time, because we monitor how much time it takes to process a message. Currently, every single message from the sensor to the cloud, so an average, it takes half a second. If we see a location where it starts 5-10 minutes of processing, something is wrong, or even goes below 0. Okay, something is wrong there. So this affects the data quality because then the timestamp is different, time is different, maybe the reports probably will be wrong. For example, we ingest alarms in events. When I say alarms in events, is for example when a pump starts shaking too much, or there is a leak. There is a leak. That's very dangerous. If this timestamp is different, then when they are doing BI or dashboards with the alarms that are happening, there will be an alert that already happened, or they will not see it because the timestamp is different, because maybe it's 2 days ago, and then it's happening now. So the process, the availability. Yes, sorry.
No, I was going to say that I could see that being a big issue, especially if you're looking to combine data sources from different terminals, locations, and if one of them is off, that could definitely cause an issue with not only the data but also the confidence in the data as well. When the operational folks to start to have questioning the authenticity or the reliability of the data. So I can certainly appreciate that. And that's a great example of some of the things that I'd say there's a fair amount of, data engineers work in the conventional space that don't have to worry about those differences of, timestamp syncs. They're dealing with just, one source DB or a handful of them that have a consistent timestamp when you're dealing with, thousands of devices with different timestamps associated with them. So,
then we have the already mentioned the reliability and availability, the throughput. It already happened that we sent so many messages that we shut down the internet in the terminal. By making this, the terminal was not able to operate. They were not able to open the ERP, CRM, everything was down because of us. We have places where the internet is very, very reduced, and the reason is because of safety. A lot of our terminals are located or placed very far away from civilization for safety. When something goes wrong, a huge leak, it can happen that the city needs to be evacuated. I think it never happened, to be honest, but it can happen. And then we have security. If people listening to this, they start Googling industrial hacking, they will find like Colonial Pipeline that was hacked last year. A lot of companies in the United States, industrial companies, have been hacked to manufacturers. They just hampered the production. Most of the times it's governments, states sponsored attacks, but well, it can happen, and the consequence can be huge, from people, money, everything. Imagine a tank, and we say that the product is cold, and we start pumping a product and it needs to be hot, and because of that it starts fire, an explosion. Who knows? Because it's industrial chemicals. The reaction of them can be dangerous. So security is very in mind with us. Everything was designed with security in mind first. Security and automation, because at our scales, if you want to deploy or redeploy or bug fixing or migrate data or fix your schema, for example, if you change your schema of your data, you need to fix it in the cloud. For example, it's 8 billion records, but in the fly, in your in your ETL at the edge, you need to fix it too. So our security, it's number one. We have proxies, a lot of firewalls, certificates everywhere. We have a big SOC team too that helped us.
Gotcha.
Yeah.
Yeah.
Yes.
Oh, go ahead.
So, and we have another challenge that I already spoke is doing it with a small team. If I look this at other teams, at other companies building this type of systems that process this amount of information, they have like a huge team. And we did it with 3-4 people. It's quite amazing. The team will not change a lot, by the way. Only if someone leaves, that I hope not. But it's very small, very high performance, a very senior team, which allows us to be very confident, build a very confident product. When I say to people that our code base it's 99.5 test covered, and we have unit tests, regression tests, smoke tests, low performance tests, and all this is automated inside of a CI/CD pipeline. Our infrastructure is code in the cloud. It's automated with tests. Our deployments is full of tests too. We run every night, and the deployments, we test every night. The rollback example, if there is a disaster and we need to hold back. It's a lot.
That's incredible. Yeah, going back to the team size and how much you're able to accomplish with such a small number. And it sounds like you're crediting a lot of it, obviously, to the senior level talent of the team, but the automation, right? Listed some pretty impressive metrics there. And you've also mentioned that this could be a template for other teams within Voltpack, right? let's get a small team together. This is how we're able to accomplish it through automation, test coverage, all that good stuff. That's amazing. So now that we have this, go ahead.
Yeah, I was going to say regarding we have more challenges. I'm sorry, going through many challenges. We have doing upgrades without zero downtime because we still need to have time. Thanks God, IoT Greengrass allows us to do that. It caches data. It's still running. It does rolling. We can do a rolling upgrade in this case.
And what is Greengrass? What capabilities does that give you?
Once again, it allows us to run less lambdas. Not only less lambdas, but you can run Docker images locally. Imagine from an infrastructure perspective, or a developer perspective. I can run any application, lambdas, locally in a small device, and I can run Docker images on a small device. It allows this from an infrastructure point of view. You can say, oh, but I can do the same. I can deploy my Kubernetes and do the same. But it builds an infrastructure for you automatically, the authentication, the logging, the monitoring, the deployment, the tracing. It does that already for you. The security, authentication, certificates rotation. It does already
extend the AWS platform to the edge to some degree. Obviously, not all of it, but a lot of the fundamental boilerplate stuff. It gets it to the edge. Okay.
Yes, even like, for example, Secret Manager to store your secrets. You can run it at the edge, and offline. So that's one good part of Greengrass. It runs offline. If you have a company with the trucks, or you can run Greengrass in the trucks, and when the internet comes back, you resync. It depends on the size of the data, because for our case, we can store 2 hours of data on the cache, and the cache you can even configure. You can cache it in memory or in the disk.
Oh, wow. Okay.
So in our case, we store it in the disk, and we store around 2 hours of data. So if the internet goes down for 2 hours, we can resync automatically. We don't need to go to the local storage and resync it. So and going to the resync, the data migration at scale. As I told, if we are changing the schemas at the edge or at the cloud at the same time, you can see with 8 terabytes, with 8 billion records, it's a lot of data that you need to refix or change the schema. At the same as at the edge, when you are changing the schema, how do you identify then the data that is already passed or is passing at the time that you are changing the schema? That are very, and how do you test that too? A big challenge, operational, once again, probably a challenge to keep the data correct in the flow constantly.
Absolutely.
From a person, people, process, company, a challenge is introducing new technologies and methodologies. Sometimes I say this. They have this expression, the Mario expression is this: we are building an utopian dream, It's a marathon. It's not a sprint. So you introduce this technology to people that with different backgrounds, with different expectations, and they can go, whoa, this is possible. It already happened. People doing it. We show how to do data analytics with the asset information that they have, and they go, whoa, then it means that I can do this and this and this. But still, you have people that are very reluctant. They say, I already have a control system. Why do I need that? So introducing, it's a marathon. So you need to be very careful, slowly introducing, baby steps. If you do a big bang, it will cause more people to stay away and run away from you than embracing the technology.
User adoption can be tricky, right? And I think that's what you've outlined as a pretty good approach, right? You'll have some that immediately gravitate towards a solution, realize the possibilities, and want to take advantage of it. Mm-hmm. Some of the other ones are a little bit more cautious. Maybe they've been promised some other stuff prior that didn't happen, and Yeah, you need to bring them on board. It's a different tactic of doing so.
Yeah, it's the mentality of the company is becoming data-driven. It's one even of our main goals for the next years is becoming data-driven for everything, for all decisions. And we are one of the key pillars of becoming this data-driven because we provide the data that is on site of our assets, of our oil, the status of the oil, of the gas, and the industrial chemicals, of how the performance it is of the trucks, the pumps and the valves. So changing the mind is it's one big challenge. For example, our BI and data science team is doing a very good job, which they are setting up a data academy for managers and industrial engineers where they learn about what they can do with the data and with the technology that we exists.
Yeah, data literacy is very important to adoption.
Yeah. So they are creating this academy where they teach people what to use and how, because sometimes they think, I can do predictive maintenance because I went to this conference and I know it's possible, but how? So we need to teach them the how part. Yeah,
you mentioned, that was actually one of my questions is now that you've supplied this infrastructure and the associated data with it, what is Voltpack doing? There sounds like you're on a mission to become data-driven. You mentioned predictive maintenance, some advanced monitoring, things like that. Anything else come to mind?
Yes. We have energy management because we all know how the world is going. So the pollution, CO2 exposure. So we are working on energy management. So when I say energy management, we can do peak shaving. So what it means is we can, because of the data and machine learning, and we can tell the operator, there is still a person clicking yes or no before people start jumping from the chair. We tell the operator, hey, this pump is consuming energy. So it could be normal energy, could be petrol that is using to warm up, it could be other type of energy resource. So we tell the operator, do you want to shut it down? And it says yes or no, based on schedule, based on data, multiple sources, once again. And if it says yes, then the pump stops and stops consuming energy and polluting. So the predictive maintenance already told about the analytic over alarms and events, the asset performance optimization. I'm trying to go through a list, mentally list, to be helped. So we have trucks that offload and offload, and we like to know which truck was the fast and why was the fast, which chemical is faster, which route it took to go fast. We have, this is funny, we have autonomous robots, so like Boston Dynamics robots for asset inspection.
Oh, the backflip kind.
Yeah. Already told that we provide real-time data to our customers. The truck information, we can read the license plate, pass the information to ERP. We have something which is still being checked, because it can break some laws, to be honest, in some countries, is we have safety badges. What happens is if we have an operator, if he falls on the floor or stays in the strange position in a strange place for a long time, it means that he's possibly in danger. If the operator badge detects that the operator is in the ground for 30 minutes, like an example, in a place with hazard environment, something is wrong, So we collect the data. We have a smart badge that corrects this data. We have 3D modeling, so the fancy word digital twin, where we build our tanks, our pipelines, our jetties in 3D, and we can see the content in real time passing through the end of the tanks. And what is happening if they open a valve or a pump, we can see it in real time in the graph in 3D.
Gotcha. Get a visualization of what's going on operationally.
Yeah. And we something that I really like to do is we do 3D printing of sensors and equipment. We have been investing a lot in sensors, by the way. We acquired recently and in data too. We invested in companies like Data World. It's a knowledge graph company. We invested in a company that provides sensors. So we are really become data driven. We invest in companies. We invest in 3D printing and sensors. We have all these. It's what they call industrial 4.0, right? We have all these.
Oh, I've never heard that term before. You said industrial 4.
4.0.
Sorry, oh, okay.
Yeah.
So everything you've been talking about is wrapped up in this kind of industry-wide vision. Oh, excellent. And it sounds like you're well on your way for most of them.
Yeah, it was created in Germany. I think China has multiple countries has adopted their own name for this. Chinese like China future something. Okay. But in Europe it's industry 4.0. But every single country or region is adapting. They are using this one to create their own path in digitalization. They're using like a framework, a blueprint.
Gotcha. No, that makes sense. Yeah, excellent. Well, do you have any? So if there was somebody in the audience, a listener, and they were, they've been tasked with a similar project, right? IoT, working at the edge. What are some of the advice that you'd have for them?
Start small, prototype fast, and test in the field. Get some value. The reason is if you start going very big and testing with a lot of sensors from the beginning, you're gonna face a lot of challenges from the beginning, a lot, and it will take a lot of time for you to show some value.
That makes sense, right? Get that minimal viable product out there, get some feedback, do it again, right? Iterate over it again. That sounds pretty reasonable.
Another thing, this is maybe in more after this very small prototype, I will suggest to build thinking in automation, monitoring, and testing. Our mistake, for example, here I'm honest, when we start building, automation was not really in our we were first want to show some value, but then we went through the rabbit hole and we wanted to show value to every single part of the company, and we stopped looking at the automation and monitoring and testing. And then when we already live in one terminal or two, and we said, okay, now we need to deploy in 72 terminals and monitoring this. So all the things that I said about test automation, it took us more time to retrofit and redeploy, and because we were already building, but if you start building, okay, I need to automate the deployment. Let's see something. If the person that is listening only has one factory, one place, like with 10,000 sensors or 5,000 sensors, maybe this is not your priority. But if you have 10, 15, 30 locations, everyone with 10, 15, 30 sensors, then you need.
Yeah, and the uptime.
Yeah.
Right, the uptime requirements,
Yeah, and once again, going back to one of our previous topics in conversation, you already have these out of the shelf, okay? You need to evaluate and test and prototype fast to see if it fits your requirements or not, your business requirements and operational requirements and functional requirements.
Yeah.
But there is already a lot of things from cloud providers. I don't think go to Amazon or choose whatever it's better for you and what adapts to you. And test it fast and start very small 2 sensors, 3 sensors, one location max, and build a dashboard just to impress. For example, us. Yeah, it's just to give an example.
I would agree.
We built with one sensor. We built a dashboard, and for funny, we then did an Alexa skill.
Nice.
And we asked Alexa, "Can you tell me the temperature of this sensor of this tank?" And Alexa will tell us. It was just the wool factor, Okay, we can do these type of things. Yeah. That's my feedback.
The same thing that they see at the conferences. So you might as well do it there. Huh? Yeah.
Yeah. If the demo gods allows, yes.
Yeah. Exactly. If the demo gods are shining down upon us, right? That sounds good.
Yeah.
Well, hey, Mario, I really appreciate you coming on the show. This has been a great episode. Thanks so much.
Thank you.
All right. Bye-bye. Listeners, please like, review, and subscribe. And until next time, thanks so much.
Thank you.